Hello everyone. Today we're looking at types of substances, in particular ionic materials, and how the atoms are bonded together and the properties of these materials and how to name them. Now, the structure of ionic materials is that there are positive ions, which are called cations, and negative ions which are called anions. These are often a metal and a non-metal. The ions are held strongly together by electrostatic forces, and they form a three-dimensional lattice. So if you think of a lattice as being a sequence, or like one after the other, we've got a chloride ion here, a sodium ion here, another chloride, another sodium. You can see the pattern is forming. Now when these form as a 3D lattice, not only are they in a pattern across, also down, but also back to front as well. Now, if all of those are attracted strongly to each other, then obviously you're going to have a very strong crystal, and that's why we get some of the properties of these ionic materials. Some of the properties include they are non-conductors of electricity. Now, if you put a big charge on the left-hand side here and another one over here, say for example we put a strong negative charge over here, we connect up to like a big battery or something, we put a strong positive charge over here. None of these ions are free to move, so nothing's going to happen. There's no way that any electricity can pass through that material. If, however, we melt the crystal so that everything is free to move and move around, then yes, when you put a negative here and a positive here, then the whole thing, the ions can move and you get electric charge happening, electric current flowing. Same thing if you dissolve it in water, for example, then the ions are free to move and you get an electric current will flow. Now, because these ions are stuck very strongly together by the electrostatic forces, that's the positive on this one is attracted to the negative on this one, and the negative on this one is attracted to the positives all around it, then it's difficult to melt it. You have to take it up to a very high temperature to melt it, and it's also brittle, which means that if you do happen to crack it down, say one of these along the line down here, if you crack it open, then once those forces are broken, then they won't go back again and the material will be broken. One of the reasons for that is if I push this sodium and push this whole line down a little bit so that this sodium ion is opposite this one, okay, if these two are opposite each other, then they will repel each other and the crack will form and the material will break. Now we do need to learn the names of all the ions, or a lot of the different ions. You really can't understand these materials if you don't know the names of the ions. So here is the cations, all the cations. There's some which have a single positive charge, which means the original atom has lost just one electron, leaving a positive cation behind. There's lithium, sodium, potassium, silver, hydrogen. This one's a little bit different because this one's got three atoms joined together, but overall it's got a positive charge, just one. And copper and mercury also form a single positive charged ion, a cation. It is possible for an atom to lose more than one electron, and then we'll have a double charged ion. This one is magnesium, calcium is 2+, strontium, barium, copper 2. Now, some of these elements, they've got more than one kind of ion. So here's copper 1, okay, that just means a single positive charge. If it's called copper 2, then it's a double plus. Lead 2 has got 2, zinc has got 2, manganese is 2, iron 2 is 2, and tin 2 is 2. You can also get 3+ ions. Aluminium goes to 3+, so does iron 3 and chromium. You need to learn those. There's also the negative ions, which are the anions. Hydride is not very common, but you can get a hydride of a metal forming. These ones are all pretty common: fluorine or fluoride ion, chloride ion, bromide, iodide, hydroxide. Now once again, this one has got two elements in the ion, but overall if you have OH it tends to have lost one electron, so it's a single negative charge. Here's another, what we call polyatomic ion with 4 atoms, 1 nitrogen, 3 oxygen. It's got a single minus. Hydrogen carbonate, single minus. Nitrite, nitrite is single minus, and permanganate, MnO4, single minus. There's also a possibility of -2 ions, oxide, sulfide, carbonate, sulfate, sulfite, dichromate, and chromate. And there's also these 3 negative charges on these ones, phosphate and nitride. Now, when we name these ionic materials, you always put the name of the metal first, and then the anion. So the cation goes first, and then we get the anion after that. So, for example, looking back here, we could have maybe lithium. Okay, just get a lithium. We'll get lithium fluoride. Okay, so we wanted to name lithium fluoride. We put the lithium first and then the fluoride ion. There must be the same number of positive charges as negative charges because the overall charge on the material is 0, so the charges must add up to 0. And there is the same number of, yes, I already said that, the same number of positive and negatives. So when we name these things, for example, we could get sodium chloride, NaCl, is sodium chloride. The charge on a sodium ion is +1. The charge on a chloride ion is -1. So overall, the charges add up to 0. You just have one of each, so it's sodium chloride. In the case of calcium chloride, we've got calcium has got a 2+ charge, and chloride has a 1-. So if we just have 1 calcium and 1 chloride, it's not going to add up to 0. It's going to add up to +1, so that's no good. We're going to need twice as many chloride ions to counter the 2+ on the calcium. So we're going to have 2 of those. Okay, so the formula for this one is calcium chloride with a 2 there. Let's there's a little, I might call it a trick you can do, working out the formula. So if I say do aluminium fluoride, how do I know what the formula is? Well, aluminium is 3+ and fluoride is 1-. And so we're going to need 3 of these. So I'm going to take this number here, 3, and put it down here. I'm going to take this -1 here, and I'm going to put the 1 there. So the formula is Al1F3. But the thing is, you don't need to put the 1 in. So I'll just take the 1 off, and so the formula is AlF3. I'll do one more. What about sodium carbonate? NaCO3. So sodium is a +1. And carbonate is -2. So what I'm going to do is I'm going to take this 2 and put it here. And I'm going to take this +1. I'm going to put it here, except I don't need to put anything there. I should perhaps mention that if it's a polyatomic ion, like this, you might need to use some brackets. So let's put calcium. Let's just pick an ion. What about calcium nitrate? Okay, so calcium is 2+, and nitrate is 1-. So it's NO3, 1-. We're going to need twice as many nitrates as calciums, but if we put a 2 here, we're going to have something that looks like 32, and that's no good. So we're going to put a bracket there. Now we can put the 2 there. Okay, so the formula for calcium nitrate is CaNO3 2.